There, let's talk about capacitance. So a capacitance of a capacitor is the ratio of the magnitude of the charge to the magnitude of the potential difference between the conductor. So capacitance of the capacitor is the ratio of the magnitude of the charge to the magnitude of the potential difference between the conductor, and it is given by the formula: capacitance is equivalent to charge divided by the potential difference, where the Q is the magnitude of the charge and V is the magnitude of the potential difference measured in volts, and the capacitance C is represented by C in farads. So what we should know again is that when a capacitor is charged, it can store energy that can be reclaimed when needed for a specific application. So a capacitance can store energy. So this is the simple mechanism of a capacitor. It consists of two plates which are connected to the battery, which is the source of power. So when the connection is made, electrons will be transferred or will be pulled from one of the plates, from one of these plates to through the battery to the other plate, leaving this other plate to be negative and the other plate will be positive. And this transfer, this movement of electrons will stop when the potential difference in the battery is equals to the potential difference in the capacitor there. So let's have an example. We see how we can calculate capacitance given the charge and the voltage. So our example is saying the plate of a capacitor holds positive 2500 microcoulomb and negative 2500 microcoulomb of charge respectively, when the potential difference is 850 volts. So what is the capacitance? So I have been given the charge and the voltage. What is the capacitance? So we are going to use this formula here, which is capacitance is equals to charge over voltage, where Q is the magnitude of the charge, so Q will be positive. So here I'm going to pick one of these and take its magnitude. So the magnitude of positive 2500 microcoulomb is simply 2500. So the formula is capacitance is equals to charge over voltage. So our charge is 2500 microcoulomb and our voltage is 850 volts. So dividing 2500 microcoulomb by 850 volts, we are going to have 2.94 microfarads, so which is equals to 2.94 by 10 to the power negative 6 farads. So this symbol there, it's simply micro, it can be represented by 10 to the power negative 6. So that is the capacitance of this capacitor with the charge 2500 microcoulomb, which is connected to the potential difference of 850 volts. So this is the one of the formula you can use to calculate capacitance. We have another formula, which is capacitance is equals to permittivity of free space, which is represented by this letter here, which is epsilon, multiplied by area over distance. So this formula comes from this same formula here, in such a way that our formula, the first formula, we said it is charge over V, and we know that our charge under electric field and the electric charges and electric field topic, charge is equals to charge density multiplied by area, where this symbol there, which is sigma, is what we call charge density. So charge can be equal to with charge density multiplied by area, and then this V voltage is equals to electric field multiplied by the distance. We discussed about this in my previous video, where we said voltage is equals to EG, and then from there E, which is electric field, is also equals to charge density over the epsilon, which is the permittivity of the free space, multiplied by this is electric field, and then multiplied by the distance d. So if here we are going to have our sigma, which is the charge density, is going to cancel, and we are going to remain with this formula here, where this epsilon is what we call the permittivity of free space, and it is a constant, which is 8.85 by 10 to the power negative 12 coulomb squared per Newton meter squared. And then A is the area in meters, and distance also in meters. So that's what that formula is saying. Capacitance is equals to permittivity of free space multiplied by area divided by distance. So that is another formula you can use to calculate capacitance. So if you have a capacitor like this one here, so what we do, we simply divide the area by the distance which separates the two plates. Remember, this distance here is the distance that separates the two plates of a capacitor. So that the distance there. Then we divide the area by the distance and multiply it with the constant epsilon, which is the permittivity of free space. Then we find our capacitor. For example, we have this question here which says, consider the earth and a cloud layer 8.0 by 10 to the power 2 meters above the planet to be the plates of a parallel plate capacitor. Then A, they are saying, if the cloud layer has an area of 1.0 kilometer squared, which is equals to 1.0 by 10 to the power 6 meter squared, what is the capacitance? So this question is saying, consider the earth and the cloud. So we have two things here, the earth and the cloud, and this earth and this cloud here is separated by the distance 8.0 by 10 to the power 2 meters. So the cloud is 8.0 by 10 to the power 2 meters above the ground. So consider the planet, which is the earth, to be plates of a parallel plate capacitor. So the earth and the cloud are two parallel plates separated by the distance. This distance is 8.0 by 10 to the power 2, this figure there. So the question is, if the area of the cloud is 1.0 by 10 to the power 6 meter squared, what is the capacitance of the capacitor? So we are going to use this formula here, the formula which we have come up with, which is area divided by distance there multiplied by the constant is equals to capacitor, where A is the area. We have already been given the area of the cloud is there, and then the distance which separates the earth and the cloud is 8.0 by 10 to the power 2 meters. So what is the capacitance? So this E is 8.85 by 10 to the power negative 2, which is a constant we are going to be given, and then D is the distance that separates the two plates, which is the earth and the cloud in this case, and A is the area, which is 1.1 by 10 to the power 6, the area we already been given here, which is the area of the cloud. and then we're multiplying this figure here by that figure and divide by the distance which separates the two plates. We are going to find that our capacitance will be 1.11 by 10 to the power negative 8 farads. So that is question A. That is the capacitance. The capacitor is that. So question B says, if an electric field strength greater than 3.0 by 10 to the power 6 newtons per coulomb causes the air to break down and conduct charge, which is the lightning, what is the maximum charge the cloud can hold? So we have been given the electric field and we have been asked to find the maximum charge. So to find the charge, we are going to use that other formula, which is capacitance is equals to charge over voltage over voltage. So here we are finding the charge, and the capacitance, we know the capacitance, we have already calculated it. But now what is this voltage? So we need to calculate the voltage. So we need to find the potential difference. That's when we are going to replace in this formula to find the charge. So our voltage, we know that it is equals to, potential difference is equals to electric field multiplied by the distance. So the distance, we already know it, and the electric field is 3 by 10 to the power 6 newtons per coulomb. So we are going to say our electric field, which is 3.0 by 10 to the power 6 newtons per coulomb, multiplied by the distance which separates the two plates, which was 8 by 10 to the power 2 meters. So multiplying the two, we are going to find that our voltage will be 2.4 by 10 to the power 9 volts. So we have our voltage. Now we need to calculate the capacitance, the charge. So the charge. So to find the charge, we are going to use this formula, but let's first make Q the subject of the formula because we are looking for the charge. So our Q will be simply capacitance multiplied by the voltage there. So our capacitance, we already found it. It is this one here, which is 1.11 by 10 to the power negative 8. So we're going to replace it where there is a capacitance there, and our voltage, we already have found it, which is 2.4 by 10 to the power 9 volts. So if you punch that on the calculator, then we're going to find that our charge is simply 26.64 coulombs, which is simply 27 coulombs. So that's how we can calculate the capacitance using those two formulas. So thank you very much for watching. Don't forget to like and subscribe. And remember, when you subscribe, you won't miss any of my videos. And leave your comment concerning this video in the comment section below.